So this goal is that you can classify triangles. So we're studying our unit on congruent triangles. And so what we're really going to be focusing on is like, what kind of information do I need? Like, what kind of information do I need to say that the triangles are congruent? But first, we're going to just kind of talk about triangles and make sure we know our main facts of triangles. And so today we're going to classify triangles. We classified angles, so we're going to classify triangles two ways. We're going to classify triangles by the angles and by their side measures. So when you're naming these, you should have two different names. So we will learn these different names as we go along. So the first way we're going to classify is by their angles. So remember, an acute angle is an angle that is less than 90. So an acute triangle, it has 3 acute angles. So all of the angles in the triangle are acute. An equilateral triangle, or equal angular, you can again see that word kind of equal there, equal angles, so that all the angles are congruent. Obtuse has one obtuse angle, so one angle that is larger than 90, and the other 2 would be acute. And then right has one right angle, and again the other 2 would be acute. And we'll learn kind of why that is on our next goal. And then so here we're classifying it. Notice all my angles are equal, so this would be equiangular. Looking at my angles, I see this one angle that's greater than 90, so one obtuse angle, so this is obtuse. All right, we are classifying A, D, E, so when I look at A to D to E, that draws this triangle right here, and I can see that this angle right here, for that to be that window, is 90 degrees. So since it has one 90-degree angle, it is considered right. So acute is the only one that all of them are acute. Otherwise, these just have one of the types of angles, and then again, equiangular means equal angles. All right, so X, Y, Z, notice a few things. When we're naming these triangles, we have a picture or drawing a triangle, and we're naming it by the 3 vertices. So X, Y, Z draws this triangle, and the angles of that triangle are 50, 40, and 40 plus 50, which is 90. So because we have this 190 degree, this would be in a right triangle. All right, looking at here, we do not have a right angle in there. We do not have an obtuse angle. They're not equal, so they are all less than 90, so this would be acute. The second way that we're going to classify triangles are by their sides. So we looked at their angles, and now we're going to look at their sides. So this is equilateral, and a few ways that we know sides are equal is by these little tally marks. So if it has the same number of tally marks, then that's the sides that are equal. And again, we kind of see that word equal, and then lateral means side to side. If you run laterals, you're running side to side. Isosceles has 2 equal sides, or 2 congruent sides. And scalene, none of the sides are congruent. So the triangle truss shown is modeled for steel construction, classified JMO. So triangle JMO, or JMN, JMN, J to M to N. And it looks like, when I'm looking at that none of the sides are equal. So that would be scalene. JKO, triangle JKO is this triangle here, which is also scalene. And triangle OLN OLN. All those sides look equal, so that would be equilateral. Right, looking at measures then, if sides are congruent, they'd also be equal. So y is the midpoint of Vx. Remember, midpoint means halfway point. So y is in between Vx. So halfway point here. So that means if this whole Vx is 8.4, this would be 4.2, and this would be 4.2. Wy is 3 units long. And we're going to classify whether or not Vwy is equilateral, and it's not because none of the sides are congruent. Isosceles, no, so it would be scaly. So here we see this is 1.2, and then C again is the midpoint of BD, so it's halfway, so I take half of 3.4 and get 1.7. So we're looking at triangle ABC, and we see it has 2 equal sides, so it'd be isosceles. And then you can keep going there. And then we can use what we know. So find the measures of the sides of an isosceles triangle, given that KLM is the triangle. It's an isosceles triangle, so that means 2 sides equal. And KL is the base. So when we're talking an isosceles triangle, the side that is not equal to the other 2 sides is the base. So KL is the one that isn't equal. So that would mean that 4D minus 13 equals 12 minus D. Then you're going to add your D over. So I get 5D. And I'm going to add 13 over this way. And it gets 25. And then divide by 5. So D equals 5. And again, I'm not looking for what D equals, but what each side equals. So this would be 5 plus 6, which equals 11. This one would be 12 minus 5, which is 7. And this should equal the same as 7 because these were the 2 equal sides. 4 times 5 minus 13 is 7. So those are my 3 side lengths. Right? ABC is an equilateral triangle. We don't really have to see the triangle because we know equilateral means all the sides are equal. So I can put any of these 2 sides equal to each other and solve for x. So I did 6x minus 8 equals 7 plus x. Subtract my x over. I get 5x equals 15, and divide by 5. So x equals 3, and when I plug 3 in for x, I get 7 plus 3, which equals 10, and all of these would also equal 10. So x equals 3, and all sides are 10. Right. And that is the end of the lesson. Let me know if you have any questions.